it would behoove us to understand this term IP. And so IP, of course, is Internet Protocol. You may think, oh, I got that one, right? Internet, I know what the Internet is. That's not what IP is even referenced to. The word Internet is like the word interstate highway. An interstate highway connects state to state to state. Internet is simply communications across networks, across many networks. And so this word Internet, it refers to a standard set of rules that define how computer networks communicate, because that's what protocol is. It's nothing but a standard set of rules. TCP/IP, TCP/IP, is the formal designation for IP. So when we say IP anything, what we're really referring to is TCP/IP. And there are a lot of network protocols out there, lots and lots of them. But you have to know that TCP/IP is the most prevalent by far. I mean, think about it. The Internet uses TCP/IP as its protocol. Also Ethernet, and we'll talk about Ethernet in some detail. But Ethernet, it also uses TCP/IP as its protocol. And so another thing you need to know about IP and about an IP network is that an IP network transmits data in packets. In order to get data from one point to another, it has to break it up into little packages and send those packages from point A to point B. That's what we should know about IP. Let's work now on some actual applications of IP. And we talked about voice over IP. We might also talk about IP video, and we'll refer to IP video as anything, maybe video conferencing or even video surveillance. And so voice and video signals, traditionally, they traveled over analog circuits. You'll see that diagram on the right there, upper right. Analog circuits is really just a factor of amplitude over time. That's the way it was done. Of course, that's been around for 100 years. Mr. Marconi is the one who sort of discovered how those analog signals work. But analog signals were converted to digital signals, digital being ones and zeros. And the reason that analog had to be converted to digital is because computers speak digital. Really, computers only know two things at all. They know on and off. They know 1 and 0. Voice over IP, that particular application converts these digital signals, the stream of ones and zeros, into the IP protocol so that entities on both ends of the circuit can interpret it. And this stream of ones and zeros gets broken up into packets simply to ensure that they all get to the destination intact. And here it is, TCP/IP is simply the set of rules that the packets follow. Think about cars on an interstate highway. The cars have to have rules, the packets have to have rules. So, what should I know so far? You're going to see these slides come up occasionally just to remind us of what we should have learned so far, just as a little reminder. So far, what we should have is that there's one really big network. And that network, the one big network, is a network that includes every single network. It includes every LAN, every WAN, it includes the Internet, it includes the cloud, whatever that is, and it even includes your home network, that little network you have at your house. That maybe is a wireless router and a few devices. The network that we're talking about includes that one as well. This network that we're talking about, that network is an IP network. It is. It's an IP network. That means that it uses TCP/IP as its protocol, as its set of rules, and it sends data in packets. That's what we need to know at that point. Now, that network, the one we're talking about, that network connects everything to everything, which brings us to these topics of machine to machine and big data, big storage, big analytics. Finally, voice and video travel on that network as well, not just data. And so this is it's important that we understand sort of the bigness of this network and how it all might work.